Another sub day for Mr. Paramo. It is what it is. I think what I'm doing tomorrow is I should be with the PE students, and I should be teaching freshmen and sophomores in regular PE who want to learn how to pole vault. That's what I'm going to be doing, and we're hoping that a few pole vaulters or a couple of new faces might join the track team because they got to experience it in regular physical education. Anyways, we're just going to give it a shot, and that's where I'll be at right now. You might see me later today. Who knows? Okay. So, I need to finish notes from what we did last time. Let's see if I can't find a couple things. By the way, let's say you are a sophomore, and you wonder, what did we do last time? Well, I did not finish the 7.3 notes, but I did do one recording, and that recording is on this website. So as you look at this screen here, on the website, on Buchanan's, or on my website, which remember I have a tinyurl.com/Nick Paramo. Otherwise, you can find it off of the Buchanan website. You can look and see that on Thursday that we had 7.4, DHQ 7.3, which is something that we are going to postpone for next time. But there's a little button that says notes. And I actually have a link under the description of the notes, so you'll be able to click there and find the first half notes. It's 6 minutes long, and the answers weren't there. And it really just goes through how we figured out what asymptotes were what. And there was a lot of discovery. If I were you, I don't know if I would go back and watch those notes. They're there if you need them. But I would probably read through all the notes and then ask somebody who's not a sophomore who might be able to help you out. Discover what the rules were that we were talking about. So I want to get back to this. And I'll just go over one last example, and maybe you'll get this as we go through. Notice that this question says, without a calculator, find all asymptotes of the rational function. So when I look at this, it had everything to do with the degrees of the highest degree of the numerator, the highest degree of the denominator. If I'm looking at the highest degree, first off, I'm referring to the horizontal asymptotes. The horizontal asymptotes are the ones that go left and right. Those are y equals graphs. So it has everything to do, look at the arrow of this mouse, it has everything to do with the highest degree of the numerator versus the highest degree of the denominator. So when I look at this, the highest degree is in the denominator. What does that mean? If the highest degree is in the denominator, every single time the horizontal asymptote will be y equals 0. And the vertical asymptote is where the denominator equals 0. Well, will the denominator ever equal 0 here? Let me see. Negative 1/3 squared wouldn't be negative. So there's no vertical asymptote. There's none. The horizontal asymptote, y is equal to 0 because the degree is bigger on bottom. Find all asymptotes of the rational function. That's all we had to find. That's it. But there was something different if the degrees were the same. If the degrees were the same. If the degrees were the same, it's always y equals, we're talking about the horizontal asymptotes, the horizontal ones. The horizontal asymptote would be at y equals whatever this coefficient is divided by this coefficient. That means the horizontal asymptote for this g of x is y equals 2. Now what about vertical asymptotes? Where could the denominator equal 0? 1 or negative 1? So there's 2 vertical asymptotes here. Don't forget to label when is which. The asymptotes are x equals, remember I have to know which one's the vertical. VA is going to be vertical asymptote. If you forget the VA, you won't get. If you forget the x equals part, you won't get full credit. If you forget the plus positive or the negative. If you only have one of them, you won't get full credit. So make sure you understand this. If you need help, get extra help from a neighbor, and that should help you out with the vertical asymptote. Label your horizontal, HA. HA, the horizontal asymptote is 2, because 2 divided by 1 is 2, and it's y equals the same degree is what matters. If you're asking yourself what happens if the degree is higher in the numerator, you will find that out in section 4. Okay? So, now I need to talk to you about a new concept that we haven't talked about yet, which is called a hole. Don't tell your parents that I called you an a-hole in class, because what I'm talking about is a hole. It cracks me up. I think I'm funny. Okay. Okay, so let's say you were to take this over here and you were to graph it and plug it in to a graphing calculator, and you were to plug the one on the right into your calculator. You may look at these two things and go, man, I have no idea what this would look like, but let me plug it into the calculator for you. This is plugged into something called Desmos, and then I overlaid it with a couple of asymptotes. So right now I can see that I have a vertical asymptote at x equals 3. I have a horizontal asymptote at y equals 1. This is what the calculator would show me. It would not show me the asymptotes. I would have to draw those in there, but I wanted to draw them in there just to show you. Now, if I did the second one, g of x, this is what the graph would look like. Look at these two graphs. Do they look the same to you? Are there any differences? So as you're looking at it, I'm hoping this is what you're thinking. I don't see any difference, Mr. Paramo. I'm hoping you look at that and say, those two graphs look exactly the same to me. They should look exactly the same. They almost are. There's only one difference. Look at these equations. When I look at these two equations, are the two equations the same? Kind of. No, not really. Let's see. What happens if I were to take f of x and I were to factor the numerator and factor the denominator? Let's take a look and see what that would look like. Okay? It says that the numerator, when I factor it, would be x minus 1 times x plus 2. Let's double check that real quick. I agree with that. And the denominator would be x minus 3, x plus 2. I agree with that. So this f of x is the same thing as this blue equation over here that I'm pointing at. And this looks very similar to that. As a matter of fact, when I look at this, the x plus 2 and the x plus 2 would reduce or cancel out. It would reduce to 1. X plus 2 goes into x plus 2 one time. And if I did that, then I would have the same equation as g of x, with one catch. I want to say these are the same exact equation except for one thing. Let's look at this before anything cancels, before I cancel anything, before I reduce, I should say, because cancel is not the correct word, I'm sorry. I should say before I reduce. Is there something that x, right here where I'm pointing, is there something that x cannot be? What can't x be? X can't be what? Negative 2. Graph over here. 4, 3, 2, 0. Look, here's negative 2. Do I have a point right at? It looks like it, doesn't it? But ultimately, there is not a point there because it can't be. Because if I plug in negative 2, I'm going to divide by 0. And notice, If I plug in -2, I'm dividing by 0. Does it create an asymptote? Is it approaching infinity at -2? So, that gives us two things here. These two equations may look the same, but they are not. They are the same at all but one point. That means every single point is the same. All these points here are going to be the same as these points here. All these points down here are the same as these points here, except for one place. This one, g of x, can x be 2 on g of x? Yes. On f of x, can x equal -2? No. So what do I have to do? I have to draw a hole on the left graph. This is a hole. We're going to use an open circle, just like this red dot is right here, to represent a hole. And a hole is basically telling you that there is a removable piece of this graph. There is a place that is technically undefined. But it is not an asymptote. Let me move my face out of the way so you can see what this says. F of x has a limited domain. X can equal -2 or 3. Even though this cancels, there's still a limited domain. Don't forget what it can't be. Even though the x plus 2 reduces, with that, there is still a domain restriction on the function. It creates a hole in the graph. That does not show up on the on graphing calculator, so we have to add them in. This is going to need to be a part of your graphs as you do them. By the way, where would this exist? Where does the hole? It's -2 what? There's a way to figure that out. If I want to know where the hole is, all I have to do is plug in -2 into the simplified formula. Remember, these two things are the same. But if I were to plug in -2 here and -2 there, up here, this is where these numbers are. I don't know why I didn't. I got to fix that. I got to fix lots of things. You know how that is. -2 minus 1 equals -3. -2 minus 3 is -5, but a negative divided by negative is a positive 3/5. So when x is -2, the y coordinate would be 3/5 up. So that's where that hole is located. So now you know how to find the hole. How did I find the hole? Review real quick. I factor. After I factor, I look to see if anything can reduce. If it can, that creates a hole. Over here, is there still going to be a vertical asymptote at x equals 3? Yes. Is there going to be a vertical asymptote at x equals -2? No. Is the degree the same and the degree the same, and I'm going to have a horizontal asymptote at y equals 1? Yes. I'm hoping all that's making sense to you, because that's basically what we're going to be asking you to do, is find any holes or find any vertical asymptotes, and you need to know the difference. Just a reminder, holes aren't vertical asymptotes. They're a place where the function is undefined. You can always find where the hole is located by plugging it back in. That's exactly what we did down here to find where the hole was. Notice the hole was an ordered pair. That's where it is. And graphically, we would just draw a circle, an open circle right there as well. And you have to do that. If you're graphing a graph that has a hole in it, you have to add that in there. It will not show up on any graphing calculator or computer software.